Hello students, Mr. Madison here with a second video key for you. This practice that you see right here in front of me on the table is your second practice on the topic of arc length. I thought that it would be more helpful for you if you would be able to watch as I work the problems out. And at the end, we'll have answers to all 12 of these problems. In addition, you'll see the process involved with getting those answers. So the whole idea is to be able to have you be able to see how to do the problem. I could just give you a key with the answers, but I think that this will be more valuable, more helpful to you. So we're just going to start, and I'm going to run through and do all 12 problems for you. If something happens as I'm doing these problems that you can't follow, then what I would like you to do is email me and just ask me the question, something to the effect of, hey, Mr. Madison, on problem number 6, could you give me a few pointers on that? I didn't follow how you did that in the video key. So that's what we need to do. I'm hopeful that the whole process here, me doing this for you here, and me encouraging you to reach out to me with your questions will help you learn this material. So here we go. First thing I'm going to do here right in this block for problem number 1 is that I'm going to write down our arc length formula. This, students, is the primary tool that we are using, AL for arc length. And we know that the arc length is a certain fractional part of the circumference. That fraction is determined by taking the degree measure of the arc and dividing by 360. And then we multiply by the circumference, which would be 2 pi r. So this is our primary tool. And just about every one of these problems, you're going to use this. So in problem number 1, we're asked to find the arc length of arc RS that goes from R to S along the circle here. We're going to put the 120 in for X, so we're going to have arc length is equal to 120 divided by 360 times 2 times pi times the radius, which is given as 15. Now, when you find your answers to these arc length problems, anytime you're finding arc length or you're finding circumference, your answer is going to be in terms of pi. So this pi right here is going to be in the answer. And I can go ahead and put pi down. Then I just have to do my arithmetic. So I'm going to demo what I would do here. You can just do this calculation on your calculator. If you're going to do this on your calculator, you would do 120 times 2 times 15. And then divide all that by 360. I know that 120 out of 360 is 1/3. And 1/3 of 15 is 5 times 2 would be 10. Arc length is always a measure of distance. So this would be 10 pi inches for our answer to problem number 1. In problem number 2, we're trying to find the arc length of arc TPK. So that's from T all the way around the long way to K here. So be careful here. And what I'm referring to when I'm asking you to be careful is this top number here. Remember, this number in the numerator represents the degree measure of the arc that you are trying to find the length of. So this arc from T to K here is 120. The arc from T all the way around to K, the major arc, would be 360 minus 120, which would be 240. So when I go to find the arc length here, I'm going to put 240 over 360 times 2 times pi times the radius, which is 24. I'm going to leave a pi in my answer. I have to do my arithmetic on this. Maybe I'll just use a little mental math. Again, if you're doing this on your calculator exclusively, you would do 240 times 2 times 24, and then divide by 360. But I know that 240 out of 360 is really 2/3. And 3 goes into 24 8 times. So I have 2 times 2, which is 4, times 8, which would be 32 pi inches for my answer. Problem number 3 asks us to find the arc length of HW. That'd be from here to here. Plugging into my formula, I'm going to have arc length equals the degree measure of arc HW is the same as the degree measure of the central angle that intercepts that arc, which is at 36 degrees. Out of 360 times 2 times pi times the radius of 55. Once again, I'll try to do this without a calculator. I know that 36 out of 360 is 1/10. And 2 times 55 would be 110. Divided by 10 would be 11 pi inches. All right, let's look at number 4. In problem number 4, we're trying to find the arc length of CS. CS is the arc that's intercepted by the 72-degree central angle. So the degree measure of that arc is 72. When I go to find the arc length, I'll use the 72 to form my fraction. 72 out of 360 times the circumference, which is 2, times pi, times the radius, which is 40. Once again, I'm going to not use the calculator because I know that 72 out of 360 is 1/5. And 40 divided by 5 is 8, times that 2 would give me 16 pi inches. Problem number 5, we're trying to find the arc length of WT. The central angle that intercepts arc WT has a degree measure of 144. So the arc would also be 144. So the fractional part of the circumference that arc is would be 144 out of 360 times the circumference, which would be 2 times pi times a radius of 35. If I'm doing this on the calculator, I would do 144 times 2 times 35 divided by 360. I know, however, that 144 out of 360 is the same as 2/5 here, and 35 divided by 5 would be 7, and 2 times 2 is 4, times 7 would give me 28 pi inches. And that's my answer to problem number 5. Okay, in problem number 6, we're asked to find the arc length of this major arc, RQG. That's from R all the way around through Q and then stopping at G. Now, if this is 108 here, then the degree measure of arc RQG is going to be 360 minus 108. Which would be 252. So when I go to plug into my formula here for arc length, I have to put 252 over 360 times 2 times pi times the radius, which is given as 45 inches. How about we just go ahead and do this on a calculator, especially since we got that big number 252 there. I can go ahead and put the pi down. So on my calculator, I'm going to do 252 times 2 times 45 divided by 360. Enter, and I'm coming up with 63 pi inches for my answer to problem number 6. Problem number 7 is a little different kind of problem than we've done. The first 6 were just straightforward arc length problems. Number 7 has a little twist to it. Here's what we know. We know that the arc length from P to W is 13 pi inches. We also know that that angle that intercepts that arc is 90 degrees. So here's the deal. 90 degrees is 1/4 of that circle, because 90 out of 360 is 1/4. So I know that 1/4 of my circumference, and again, the 1/4 is 90 out of 360. I know that 1/4 of the circumference is equal to 13 pi. So that would mean that if I would take and multiply both sides of this equation by 4, that would mean the circumference of this circle has to be 52 pi. Now, I just want you to think about it for a second. Circumference is all the way around. So all the way around this circle is 52 pi. But from P to W is 13 pi. Wouldn't it make sense that we could find the arc length of PLW by doing a subtraction problem? 13 pi subtracted from 52 pi is going to give us 39 pi. 52 pi, which is the distance all the way around, minus the distance from P to W, 13 pi, has to give you the distance from P the long way around to W, which would be 39 pi. So that's the answer here. Arc length of PLW is 39 pi. More than one way to approach that problem. I hope that the method that I explained here makes sense to you. Let's look at problem number 8. In problem number 8, we're told that the arc length of SN, that's this little arc right here, that has a degree measure of 30, is 5 pi. And we're asked to solve for R. So look, I'm going to write my arc length formula. This is our primary tool. It's what we've been using for all these problems. But in this particular problem, what we're trying to find is R. We already know what X is. X is 30. And we already know the arc length. It's 5 pi. So the approach here is very simply this. You're going to substitute into your arc length formula the two values that you are given, and then you're going to solve for the one value, in this case the radius, that you don't know. So I'm going to have 5 pi for arc length. X is 30 times 2 times pi times R. Now at this point, it's really all algebra from here on out. We're going to use our algebra skills to isolate the variable R. Notice that you have a pi on the left and a pi on the right. Those pi's would cancel. That's what would happen if you divided both sides of your equation by pi. Now watch what I'm going to do here to get my answer for R. I'm going to write down this 5. Now, anything over here that's being multiplied by R, you need to divide by. So to get rid of that 2, I'm going to multiply by 1/2. And that would be the same as dividing by 2. Then to get rid of this 30 over 360, I'm going to multiply by the reciprocal, which would be 360 over 30. And that would isolate the R. Now I'm going to go to my calculator, and this is what I'm going to do on my calculator. And I like to do this type of calculation in a couple steps. So I'm going to go 5 times 360, and I'm going to go ahead and hit enter. Then I'm going to say divided by 2, enter, divided by 30, enter, and I'm home. And it turns out that R is equal to 30. And because the arc length is given in inches, the radius would have to be in inches. And that's your answer then to problem number 8. Let's look at number 9. In number 9, we have a similar type problem. We know the arc length from B to K, which is an 80-degree arc, has a length of 16 pi inches. What we don't know is the radius. So I'm going to plug into my arc length formula. Arc length, which is 16 pi, equals the degree measure of that arc, which is 80, divided by 360, times 2, times pi, times the radius of the circle, which we don't know, so I'm just going to put down r. The pi's would cancel, and I have to isolate the r by doing the following. I'm going to write down this 16. I need to get rid of this 2, so I multiply by a half, and I need to get rid of this fraction, so I'm going to multiply by the reciprocal, which would be 360 on top and 80 on the bottom, and that would isolate the r. Picking up my calculator, I'm going to verbalize my steps here. I would do 16 times 360. Those are the two values in the numerator. I'm going to go ahead and hit enter. I'm going to go divided by 2, enter, divided by 80, enter. And I'm coming up with a value of r of 36 inches. In problem number 10, we know the radius. We know the arc length. What we don't know is the degree measure of that arc. So that's what we have to find. So what I'm going to do is I'm going to write down my arc length formula, plugging into it what I already know. So I'm going to have arc length, which would be 21 pi, is equal to x over 360. Solving for x here. Times 2 times pi times the radius, which is 27. Here's what happens here algebraically. The pi's would cancel. I'm going to write down that 21. To isolate this x, I need to get rid of the 2, the 27, and the 360. To get rid of the 2, I'll multiply by 1/2. To get rid of the 27, I'll multiply by 1 over 27. To get rid of the 360 in the denominator, I'll multiply by the whole number, 360. And that will isolate x. So I'm going to my calculator. And here's what I'm doing. I'm doing 21 times 360. And I'm going to go ahead and hit enter. Divided by 2, enter. Divided by 27, enter. And I'm coming up with a degree measure of 140 degrees for x. All right. In problem number 11, we're again trying to find the degree measure of that angle. We know that the arc length of HS is 6 pi. We know that the radius is 45. I have 2 of my values from my formula. I have the arc length. I have the radius. I don't have the x. I'm just going to write my formula, plugging in the info that I have. So I'm going to have arc length is 6 pi. And the arc length always has to equal the degree measure of the angle, which would be x, divided by 360, times 2, times pi, times the radius, which is given as 45. Algebraically, the pi's cancel. I'm going to write down this 6. To get rid of this 2, I'm going to multiply by a half. To get rid of this 45, I'm going to multiply by 1 over 45. To get rid of this 360 in the denominator that's being divided into the x, I'm going to multiply by 360. And that will isolate the x. Going to the calculator, I've got 6 times 360, enter, divided by 2, enter, divided by 45, enter. And I'm coming up with a degree measure of 24. All right, one more to go. Let's look at problem number 12, where we're told that the arc length of KB is 4 pi. We know that the radius is 15. We do not know the degree measure of that arc. Plugging into my formula, I'm going to have arc length, which is 4 pi equals x over 360 times 2 times pi times the radius, which is given as 15. All I need to do now is a little bit of algebra. The pi's cancel. I'm going to write down that 4. To isolate the x, I need to get rid of the 2 and the 15 and the 360. To eliminate the 2, I'm going to multiply by 1/2. To eliminate the 15, I'll multiply by 1 over 15. To eliminate the 360 that's being divided into the x, I'll do the opposite operation, so I'll multiply by 360, and that will isolate the x. Going to the calculator at this point, I'm going to do 4 times 360, enter, divided by 2, enter, divided by 15, enter, and I'm coming up with the degree measure of 48. Now, you may not do your algebra the way I'm doing it, and that's fine. I'm just giving you one way to do it. You may not like that I do my calculation in steps and have to hit enter a few times. I just do that because I think it's a little quicker, and I'm making sure that I follow order of operation when I do that. So there you have it. These are the answers to your second practice on arc length. And I hope that my presentation here is helpful. One of the things you can always do if you want to get good at something is to practice. So any of these problems that you got wrong, a good thing to do would be to maybe redraw the problem on a fresh sheet of paper and rework the problem. And that's how you get things into your long-term memory. So students, I hope this was helpful. Thank you for your attention. You can expect to have several more practices involving arc length before we get to our quiz. So thank you once again. Have a great day, everybody.